Suppose you were asked to graph y equals x squared minus 4x minus 5. This is not in graphing form. We can't really tell the vertex, so we have to use our formula, the opposite of b over 2a. And when we do, we get 4 over 2, which is 2. And we plug that value in. So we're going to square that, minus 4 times 2, minus 5. And we get negative 8. So our vertex would be 2, negative 8. And then we can plot that, counting by ones. Okay, so then once we know that, remember we would use the fact that it is the same as the parent graph. It's not stretched or compressed. So we're going to go over 1, up 1. It opens up because the value of a is positive 1. Over 2, up 4. Over 3, up 9. Just squaring the over number, the x. And then we can see we get our parabola. Okay? So explain how to find the x-intercepts of this same parabola. Well, to find the x-intercepts of any function, you let y equal 0 and solve for x. So it looks like this. Okay, so we would have, this would be a quadratic equation. Because the variable, the highest power is squared. And if I wanted to find the x-intercepts for my graph, I can just look at what they are. So here I can see that I have my x-intercepts. Are negative 1 and 5. Okay, so I can find my x-intercepts. We're going to use this process to help us solve quadratic equations. Now, I want to be clear, a quadratic function, you'll notice, has an x and a y. Y equals x squared minus 4x minus 5. You might see it in function notation where it might be written as x squared minus 4x minus 5 with the f of x. The graph of this is a parabola. Now, that's different from a quadratic equation. A quadratic equation is going to have the form x squared minus 4x minus 5 equals 0. So notice there's no y. Now, one way that we're going to use, one way to solve a quadratic equation is to graph what we're going to call the related function and find the x-intercepts. Now, you're going to hear some similar terms thrown around. We're going to be looking for the solutions to a quadratic equation. You will hear things like the zeros of the function, the x-intercepts of the function, the roots of a function. All of those zeros, x-intercepts, roots, they're all talking about the x-intercepts. It's all the same thing. And we're using those to help us find the solutions to a quadratic equation. So here was a problem that we did, that we graphed. This is a function. We have x and y. So this is a function. I could write it in function notation. This is a quadratic equation because we have, well, first of all, we don't have our y. So we have a function in terms of x, and we have it set equal to 0. And I want to solve this. Well, we're going to look at the graph. So we're going to graph the related parabola, which we already did. Graph the related function, which is right here, and find the x-intercepts. So we can see our answer for x is 2 and 4. And those are our answers. Now we're going to talk about how to solve this algebraically later, but right now we're just using our graph to solve a quadratic equation. So on this one, here was our function that we graphed, our quadratic function, and now we're being asked to solve this quadratic equation. Now, when I graph the related function and then I look for the x-intercepts, well, I can't really tell what they are. So what we're going to do right now is we're just going to say between 1 and 2, and the other one is between 4 and 5. And again, we'll have a way to do this algebraically later. It's going to involve square roots. So we'll be doing that. And I am going to show you how to do this with the calculator as well. So with the calculator, you're going to put this in Y1 to graph this. I'm not sure what my viewing window is, so Zoom 6 will give me a standard viewing window. And I'm going to graph, and I can see that sure enough, it's between 1 and 2 and 4 and 5. But I want an answer that's a little better than that. So if you click on your calculator, second, calc, and we want the 0 of the function, and you're going to notice it's going to ask you some questions, prompts, and you have to give it the answer. So left bound. So I'm going to find this one right here, the one that's between 1 and 2. So for a left bound, I'm going to put 0 because I can see that 0 is to the left, and then enter. And now notice the prompt says right bound. So I need to give it a right bound. So I'm going to say 3 for my right bound, and it actually draws in these little vertical dashed lines for me. And then now it wants me to guess. Well, you can guess 1.5 if you want, or it doesn't really matter. I'm going to guess 1. You just want to be in between your left bound and right bound. And then you get this answer. So I can see a better answer besides between 1 and 2 would be to say it's approximately, we could say x is approximately 1.42 if we rounded to the hundreds place. So that would be a way we can do that. If I wanted to find the other 0, I'm going to go second calc 0. And now this time it wants the left bound. I'm going to do it a different way. I'm going to use the arrows. I can do the arrows until I get kind of to the left, somewhere to the left of the 0 I want. Hit enter. And then use the right arrow till you get past it, so you're on the right side. And then just arrow back. And we get x is approximately 4.58. And again, it's between 4 and 5, but that's a way that you can use your calculator. These are approximations. They are not exact values. Exact values would require us to do this algebraically, and we will be doing that later. Okay, on this one, so we want to solve this equation. So we graph the related function, and we find the x-intercept, and we get x equals -2. Notice there is only one solution to this. That happens sometimes. There's only one solution. And that's when the vertex is on the x-axis. The next one, if I want to solve this quadratic equation, I'm going to graph the related parabola and look for the x-intercepts. But there are no x-intercepts. So what that means is there is no real solution. Now there is a complex solution, imaginary solution that we're going to talk about later, but right now you would just say no real solution because there are no x-intercepts. All right, now I've got something in standard form or general form. If I want to solve, and usually you see equations a little bit more frequently in this format where it's ax squared plus bx plus c equals 0. So if I wanted to solve this equation, I could graph the related parabola. And then I could look for the x-intercepts. And so here I'm just going to say between -7 and -6, and between -4 and -3. So if you prefer, you can use your calculator and do that. But I already showed you that. You could rewind this and look back and see how to do that on your calculator if you need to. On this one, if I wanted to solve this equation, notice again, there's no y in this, it's equal to 0. I graph the related function, and then I look for where it crosses the x-axis, and we can be pretty sure on here that our solutions are -3 and 1. Again, we'll be learning how to do this algebraically right now. We're just learning how to relate it to our graph and how the solution to the equation is the same as the x-intercepts of the related function. So here, what do you do if it's not equal to 0? You make it equal to 0. So also notice they put these in kind of a different order. So I would start by doing -3x squared plus 2x. I'm going to add the 11, so I get +4 equals 0. And then I would graph this and do like I did on the preceding problem, so I don't feel like I need to do this one. So that is how you solve quadratic equations. So what I would do from here is I would graph y equals -3x squared plus 2x plus 4, either by hand or with my calculator, and I would find the x-intercepts. Okay, that is how you use the graph of a quadratic function to help you solve a quadratic equation.